study guide. So f minus g of x is equal to f of x minus g of x. And so I have 2x squared minus 8x minus negative 8x squared plus 2x minus 4. Okay, so on this one, what I'm going to do is I'm going to add the opposite. So I'm going to change this to a plus, but I got to change the signs of all the signs in here to the right. So I'm going to change that to a plus, change that to a minus, change that to a plus. Okay, and then I'm going to combine like terms. So 2x plus 8x, 2x squared plus 8x squared is 10x squared. Negative 8x plus negative 2x is negative 10x plus 4. All right, now we got to look at the domain. And so for the domain, there are no restricted values here. We don't have anything inside of a square root. We don't have anything in the denominator, so there's no restricted values. So it's going to be from negative infinity to positive infinity. So because of that, the answer is going to be D. All right. So get number 2, find the domain of the function. Now on this one, we have the square root of 24 minus x. So this has to be greater than or equal to 0. So 24 minus x has to be greater than or equal to 0 because you have to be at least 0 in the square root. So I'm going to subtract 24. Negative x is greater than or equal to negative 24. Divide by negative 1. Divide by negative 1. When you divide by negative, you flip the sign. So x is less than or equal to 24. So what is that in interval notation? That would be from negative infinity up to 24, and it could equal 24, so we put a brace on it. Okay, so less than 24 is anything below 24, so from negative infinity up until 24. So that's B. 3, find the requested function and state the domain. So first off, G composition f of x equals G of f of x. So what you're going to first do is you're going to work your way inside out. So I'm going to plug in f of x into this function, 9x plus 5. So I'm going to plug that in the inside. Now I'm going to go to the g function and rewrite this function and put 9x plus 5 in for x. So 7 times 9x plus 5. Sorry about that. 9x plus 5 squared plus 4 times 9x plus 5 minus 4. Okay. Now, next, I'm going to multiply this out. Now, 9x plus 5 squared is 9x plus 5 times 9x plus 5. So I'm going to distribute. 9x times 9x is 81x squared. 9x times 5 is 45x. 5 times 9x is 45x. 5 times 5 is 25. Combine like terms, so you got 81x squared plus 90x plus 25. Okay, and that's times 7. So 7 times 81x squared, so 7 times 81 is 567x squared. 7 times 90 is 630x. 7 times 25 is 175. Okay. Now over here, I'm going to distribute there and there. So 4 times 9x would be 36x. 4 times 5 is 20. And then minus 4. Okay. So now 567x squared, that's all you got there. 630x plus 36x. So 630 plus 36 is 666. 666x. And then 175 plus 20 minus 4. 175 plus 20 is 195. 195 minus 4 is 191. Okay, so there's your solution. Now, in the course of this, there's no restricted values. So the domain, there's no restricted values. There's nothing inside of a square root. There's nothing on the denominator. So the domain will be from negative infinity to infinity. And so this one's going to have to be B. Okay. Number 4, For the given functions f and g, find the composition f of g of 8. So f composition g of 8 is equal to f of g of 8. So you work your way inside out. So I'm going to first find g of 8. So I'm going to go to the g function. G of 8 is equal to 9 times 8. I'm going to put in 8 for x minus 9. So 9 times 8, 72 minus 9, 63. So g of 8 is equal to 63. Next, what I'm going to do is I'm going to go plug this in for the f function. So now I'm going to find f of 63. Okay, so it would be 12 times 63 squared minus 2 times 63. So f of 63, you can just type that in your calculator. So 12 times 63 squared minus 2 times 63, 47,502. And so that one is a 5. Find the inverse function. So to find the inverse, we switch x and y, and then we solve for y in this new location. Okay, this isn't too bad. So I switch x and y. So you have y equals 6x plus 5. So I'm going to switch it. So I'm going to do x equals 6y plus 5. I'm going to solve for y. So subtract 5. X minus 5 equals 6y. Divide by 6. F inverse of x, y is by itself, it's equal to x minus 5 divided by 6. So that one's C. Okay. Let's go to the next one. C, does this have an inverse function? So to have an inverse function, it has to pass the horizontal line test. And this is for problems 6 and 7. Okay, 6 and 7, got them. So horizontal line test. And so this one, that fails the horizontal line test. So this one's no, because you can draw a horizontal line that crosses more than once. This one, whoops, I didn't mean to do vertical line, I'm sorry. This one passes the horizontal line test. So used to doing the vertical line test. This one passes the horizontal line test. Horizontal line test. So this one's yes. So this one's no, that one's yes. 9, an open box is made from a square piece of sheet metal 10 inches side by cutting identical squares from the corners and turning up the sides. Express the volume of the box B as a function of its length of its side, the square cut from each corner x. Okay, so we've got an open box is made from a square piece of sheet metal. So it's a square piece, 10 inches on the side. So it's 10 inches. And it's by cutting, what I'm doing is I'm cutting identical sides up. So I'm cutting a certain amount up each time. So I'll call that x. So a certain amount's being cut each time. And so as I do the volume, whoops, I don't know why I put area. The volume equals the length times the width times the height, okay? And so when I'm doing this, as I'm doing, however much I pull up is going to be x. That's going to be my height. And my length times width will be, well, whenever I'm pulling this up, I'm going to be subtracting so x would be the height. Let me explain this. I'm trying to think of how to explain this well. X is going to be the height. And so as x increases, you're going to lose x from both sides. You're going to lose 2x from both sides. So the base will be a square with sides. You're pulling it up from both sides. You're going to do 10 minus 2x. And so it's length times width times height. And so each length and width will be this. So this will be the length and the width. So it'll end up being 10 minus 2x times 10 minus 2x times x. So volume is going to be equal to x times 10 minus 2x squared. So it would be D. explain that the best. Number 9, the population of a particular country is growing at a rate of 1.7% per year. If 5,092,000 people lived there in 1999, how many people lived there in 2004? Okay, so let's establish a few things here. So why not is your starting point. So that's your starting point. And so that's going to be 5,092,000. And then T is be the number of years. And so how many years will that be? Well, it'd be 2000 or 2004 minus 1999. So it'd be 5. So I'm going to plug in 5 for T and then this for why not. So F of 5 is equal to 5,092,000 times E to the 0.017 times 5. And so we'll get a value there. So 5,092,000. Okay, and then times second E, the 0.017 times 5. So it'd be 500 or 5,543,747.304. So the closest one nearest 10,000. So nearest 10,000 would be 5,540,000. So nearest 10,000 would be this right there. So 437. So 437 would round up to 44. So that's C. Okay. A little tricky there on the rounding. Not used to rounding nearest 10,000. Okay, so the graph of y equals e to the x. Let's look at that real quick. Just say, whoops, y equals, let me get these switched over. All right. So e to the power of x graph. Okay. So it's just kind of your basic exponential graph. Okay, so we're going to transform this. The best way I would do this is just to transform it. And so e to the x, or f of x equals e to the x. G of x equals e to the x plus 2 plus 2. Now this plus 2 means this first one up here with the x, if you add the x, it's going left. So it'll be left 2. This plus 2 at the end means it's going to go up 2. So you're going to take this left 2, up 2. So it's going to go left 2, up 2. And so this will be my solution. So it'll be B. Okay, you could graph that to check it if you want. Go to your calculator, go to y equals. Let me change this one. All right, so e to the x plus 2 is left 2 and up 2. So there you go. That's not very well done there. But all right, let's go to the number 11. Graph at 5 to the power of x and log 5 of x. First off, they're going to be inverses across the y equals. These are inverses of each other. So 5 to the power of x. Okay. And log base, math. I'm going to go down to option A, log base 5 power of x. So I graph it. So you can go to math, log base, and then A. Okay, and so what they're going to do is, these are going to be, you're going to have one going through here, and the one that goes down here and goes through here, and their reflection across, they're inverses, so they reflect across the y equals x line. So you could do this in your calculator to prove it there, but reflect across, so you have an exponential, and then you have a log function. 12, use the compound interest formula to solve. Find the accumulated value of an investment that's $1,500 at 12% compounded quarterly for 3 years. So $1,500 is your initial amount. So this is the initial amount. All right. R is the rate. So it's 0.12, that's the rate. N is the number of times it's compounded per year, 4, so it's quarterly. All right. And then T is 3, so this is the number of years. So you're just going to plug those values into that formula. So A equals 1,500 times 1 plus 0.12 divided by 4 to the power of 4 times 3. So 1,500 times 1 plus 0.12 divided by 4 to the power of 4 times 3. I'm going to put 12 there. So you get 2,138.64, and that's your answer. I'll put dollars there. That one's B. 13, write this equation in equivalent exponential form. So log base 4 of 16 equals 2. So you're going to do a counterclockwise motion. So this becomes, this is your base. This will be the exponent 2, and it equals the number 16. So 4 squared equals 16. So you do a counterclockwise, you start with the base. So this starts as your base down here. This is your exponent. So this is your base. This is your exponent. And this is the number it's equal to. Okay. This is after the equal sign. Okay. Now we're going to do this in logarithmic form. So we're going to work backwards. So 4 to the power of 3 equals x. Okay. So you're going to do log. This is your base. You're going to do a counterclockwise motion again. So log base 4. And then x is your number that's equal to. And it's equal to the exponent. So the exponent goes here. This is the base. Okay, and then this is the value it's equal to. This is what's after the equal sign. Okay, so I don't know if that helps you or not, but you're just going backwards. You put the base there, do the counterclockwise motion again, and then put x there and equal to 3. So that one's B. 15, we're going to expand the logarithms here. So you got log base B. It's B of x times y to the 8th times z to the 7th. So whenever you multiply, you add. Whenever you divide, you subtract. And then you also got to bring exponents to the front. So let's kind of talk through this. So this equals log base b of x. Okay, so I'll put the first thing. Y is multiplying with it, so I'm going to multiply, and then the exponent comes in front, so it'll be 8 log base b of y. Okay, and then so it's dividing here, so you do minus, and then the exponent's 7 there, so it'll be 7 log base b of z. So that one is D. All right, 16, use the property of logarithms to condense it. Okay, so we've got 6 log base b of y plus 2 log base b of z. So we're going to write it as one logarithm. And so remember these are the exponents. And then when you add means you're going to multiply. Okay, so log base b of y to the 6th z squared. So y to the 6th, and then times, because it's adding, and then z squared. So that one is B. All right, 17, solve the exponential equation. So we have an 3x equals 18. When you have a variable as an exponent, we take the log of both sides. So equals log of 18. So you take the log of both sides. Okay. And after you do that, you can divide both sides by log of 3. So x equals log of 18 divided by log of 3. And I'll type that in my calculator. So log of 18 divided by log of 3, 2.63. So that one is D. 18, solve the logarithmic equation. So log of 4 plus x minus log of x minus 4 equals log of 3. So first thing I'm going to do is I'm going to condense the logarithm. So when you subtract, you're going to divide. So I'm going to do 1 log. I'm going to divide 4 plus x divided by x minus 4 equals log of 3. Now, since I use the 1-to-1 property, I can cancel out the logs. So I've got 4 plus x divided by x minus 4 equals 3. I can multiply both sides by x minus 4. So 4 plus x equals 3 times x minus 4. 4 plus x equals 3x minus 12. So now subtract x. 2x, add 12, it'll be 16. And divide by 2, x equals 8. And then 8 would not make that restricted, so we're good there. That's D. 19. Solve the exponential equation, express it as natural logarithms or common logarithms, and use the calculator to obtain the decimal approximation. So I've got 7e to the 5x equals 721. Oops, 721. First thing I want to do is divide by 7. So e to the 5x equals 721 divided by 7, which is 103. Now what I'm going to do is I'm going to take the ln of both sides. So you want to take ln of both sides. So 5x ln of e equals ln of 103. Whoops. ln of 103. That cancels, and so you have 5x equals this. So I'm going to divide by 5, divide by 5. X equals ln of 103 divided by 5. So there's your first answer. Now to type that in my calculator, I'm going to do the ln of 103 divided by 5. And so ln of 103 divided by 5 is 0.9. How many decimal places they want? 2 spots, 0.93. All right, 20. Now I'm going to solve this logarithmic equation. So I got log base 6 of x minus 3 equals 1. I'm going to exponentiate this and write an exponential form. So this becomes 6 to the first equals x minus 3. Okay, so 6x minus 3 equals 6. I'm going to add 3, x equals 9.